Good evening, students. Today we will discuss about physical chemistry, that is chemical equilibrium. So A to B, it is a reaction. So these are called reactants, and it is called product. It is called product. So which enter into chemical reaction is called as reactant. Which formed in the chemical reaction is called as product. So this is reactant and this is product. This is called chemical reaction. So chemical reactions are mainly divided into two types. Chemical reactions are mainly divided into two types. Irreversible reactions. Irreversible reactions and reversible reactions. Irreversible reactions and reversible reaction. So in any chemical reaction, A is converted to B. So here this is single direction reaction is called as irreversible reaction. And this is reactants to products only. The reaction takes place from reactants to product is called as irreversible reaction. Reversible reaction takes place in both directions. Reactants to products and products to reactants in both directions. But here unidirectional is called as irreversible reaction. So these are reactant, this is product. So I will give an example for these irreversible reactions, and also I will give the reversible reactions. Irreversible reactions example. First, evaporation of water in open vessel. Evaporate from water in open vessel. An example for irreversible reaction takes place in single direction only, and all decomposition also example for the irreversible reaction. I will give an example for this. 2 KClO3 gives rise 2 KCl plus 3O2, and also CaCO3 upon heating to give CaO plus CO2. These two are example for decomposition reactions, and also precipitation reactions. These are also example for irreversible reaction. Precipitation reactions example silver nitrate on reacting with sodium chloride to form silver chloride plus sodium nitrate. This is PPT, precipitate reaction. From this precipitation it is very impossible to prepare the reactants. Therefore, it is single direction reactions. Next one, and one more example, barium chloride on reacting with sulfuric acid to form barium sulfate PPT plus HCl is formed. This is also an example for the precipitation reactions. After that, fourth reaction is R-neutralization reactions are example for the irreversible reactions. I will give an example for this. NaOH on reacting with HCl to form NaCl plus H2O. R-neutralizations are single direction reactions only. Further example, I will give an example for this. Fifth example, magnesium on reacting with oxygen to form magnesium oxide. Magnesium oxide means it is ash. So from this ash it is impossible to prepare magnesium and oxygen. Therefore, it is an example for the, and one more example, hydrogen react with fluorine to form hydrogen fluoride. These all are single direction reaction. So evaporation of water, decomposition reactions, respiration reactions, neutralization reactions, and also these reactions are example for the irreversible reactions. After that, I will give an example for reversible reactions. So reversible reactions. The reactions takes place in both directions. Reactants to products and products to reactants. The reaction takes place from reactants to product is called as forward reaction. This reaction is called as forward reaction. The reaction takes place from products to reactants is called backward reaction. This reaction is called as backward reaction. I will give this reactants to both directions. Reactants to products and products to reactants. I will give an example for this. H2 plus I2 gives rise to HI. This is an example for reversible reaction. Reactants are hydrogen and iodine. Products are hydrogen iodine. This takes place in both directions. Reactants to products and products to reactants. And I will give one more example. N2 plus 3H2 gives rise to NH3. It is also an example for reversible reaction. Formation of ammonia takes place in forward reaction. Decomposition of ammonia is considered as backward reaction. Simultaneously, I will give one more example. PCl5 gives rise PCl3 plus Cl2. And also CH3 COOH plus C2H5OH gives rise CH3 COO C2H5 plus H2O. Ester formation. This reaction is called as esterification. This is also an example for this reversible reaction. So formation of hydrogen iodide, formation of ammonia, decomposition of PCl5 and formation of ester. This reaction is called as esterification. These all are examples for reversible reactions. These all are examples for reversible reactions. After that, so now we are discussing about chemical equilibrium. Chemical equilibrium. So here the topic name only chemical equilibrium. What is chemical equilibrium? What is chemical equilibrium? Chemical equilibrium. So in case of reversible reaction, A is converted into B. So A is reactant, B is called as product. So in case of reversible reaction, here two reactions are there. One reaction is forward reaction, other reaction is backward reaction. So here I will explain this one like this. So this is speed of reaction and time taken for the reaction in one axis and the rate speed of reaction on one axis. Here this is forward reaction and it is backward reaction. So forward reaction, backward reaction. So the state or the point, this point, the state or the point at which rate of forward reaction, speed of forward reaction is equal to the rate of backward reaction is called as chemical equilibrium. Here the point or the state, this point where the rate of forward reaction is equal to, simply we are saying rate of or speed of forward reaction is equal to the rate of backward reaction. In case of reversible reaction, two reactions are there. One is forward reaction, other one is backward reaction. So the speed of forward reaction is equal to the speed of backward reaction. That state at that point is called as chemical equilibrium. The state at the point at which rate of forward reaction is equal to the rate of backward reaction. For example, if the forward reaction takes place with 20 centimeters per second, same speed 20 centimeters per second is taking place by backward reaction, then that speeds both are equal. So rate of forward reaction and rate of backward reaction equal position or point or state is called as chemical equilibrium. So what are the characteristics of chemical equilibrium? Characteristics of equilibrium. Characteristics of chemical equilibrium. So first character is rate of forward reaction. Rate of forward reaction is equal to the rate of backward reaction. So rate for forward reaction speed and backward reaction both are equal. And second one, there is no change in the pressure, density, concentration and color remain unchanged. So there is no change in the pressure, density, concentration of the reactants and color. And also at equilibrium, delta G is equal to 0. This is third property. So rate of forward reaction is equal to rate of backward reaction. Pressure, density, concentration, color remain unchanged. There is no change in pressure and density, concentration and color. And also third one, delta G. Delta G means Gibbs free energy is equal to the 0. And simultaneously catalyst, effect of catalyst, it does not alters the chemical equilibrium but speed up the attaining of chemical equilibrium. This is the portion of the catalyst. And simultaneously, fifth one, the chemical equilibrium is attained by the both sides, means from either side, from reactant side or from product side. So these are there is no change in the concentration of the reactants or products in chemical equilibrium. So first one, rate of forward reaction is equal to rate of backward reaction. Pressure, density, concentration, color, no change, and delta is equal to 0. And catalyst speed up the means does not alter the rate of reaction. It will take place from reactants to products, or sometimes it takes place from attaining from products to reactants. And also concentration of the reactants and products remain unchanged during chemical equilibrium. After that, types of chemical equilibrium. Types of chemical equilibrium. Types of chemical equilibrium. So chemical equilibrium based on the physical states of reactants and products. Chemical equilibrium is mainly divided into two types. Homogeneous chemical equilibrium. Homogeneous chemical equilibrium and heterogeneous chemical equilibrium. Heterogeneous chemical equilibrium. So homogeneous means reactants and products are in same phase, same physical state, and the reactants and products are in different physical states. Different physical phase. A different physical state are different phases. So I will give an example for this. N2 plus 3H2 gives rise to NH3. Here N3 is a gas, physical state, hydrogen gas, and ammonia is also gas. All reactants and products are in same physical state or phase. Is known as homogeneous. I will give an example for this. Heterogeneous NH4HS used as H2S plus NH3. Here NH4HS is a solid and also this is gas and this is also gas. Here products are in gaseous phase and reactants are in solids, different physical state. Therefore, it is an example for heterogeneous chemical equilibrium. I will give an example for this, one more example for this. H2 plus I2 gives rise to HI. It is also an example for homogeneous. This is gas, this is gas, this is also gas. Third one, CH3 COOH plus C2H2OH gives rise CH3 COO C2H2 plus H2O. This is liquid and it is also liquid. So all are in same physical state or phase. Therefore, it is an example for homogeneous chemical equilibrium. I will give an example for this. CaCO3 gives rise CaO plus CO2. So CaCO3, it is solid. This is also solid. This is gas. So calcium carbonate is solid. Calcium oxide is also solid. CO2 is only gas. So reactants and products are in different physical state or different phase. Therefore, it is also an example for heterogeneous chemical equilibrium. Heterogeneous. So these are examples for, and I will give one more example. Ag2O plus HNO3 gives rise AgNO3 plus H2O. So here also this is gas, this is liquid, and this is liquid, this is aqueous state. So in different physical state. These are our examples for heterogeneous chemical equilibrium. So if the reactants and products are in the same physical state, that is known as homogeneous chemical equilibrium, and the reactants and products are in different physical state, that is known as heterogeneous chemical equilibrium. After that, next one. Law of mass action. So it is explained about the rate of chemical reaction. Explain about the rate of chemical reaction and also concentration of the reactants. Concentration of the reactants. This law was proposed by Goldberg and Waage. These are the scientist names. These are proposed this law. Explain about the rate of chemical reaction, concentration of the reactants. So rate of reaction at given temperature is directly proportional to the product of the active masses of the reactants. This is the law statement of this law. So rate of chemical reaction is directly proportional to the product of the active masses of the reacting substances. So what is the product? Means A plus B gives rise C. Here this A and B are called as reactant and C is called as product. C is called as product. So here rate of reaction is directly proportional to the A power. If 1 is there, here 1 is there. So this is 1 and B power 1. This is according to law of mass action. Rate of reaction is directly proportional to A power 1. The product of the active masses of the reacting substances. This law is called as law of mass action. So what is active mass? Active mass is similar to the square bracket, that is number of moles per volume, that is number of molarity. So whatever it may be, one of the concentration, molarity. So active mass equal to number of moles per volume. This is called active mass. I will give an example for this. How to calculate active mass? Calculation of active mass. So calculate the 8.5 grams of ammonia, active mass ammonia, in 4 liters of solution. So calculate the active mass of ammonia.